All right, so number 50, this is all variables. This whole problem takes place, no numbers. You know, we got big M, little m. I'll be honest with you, I strongly dislike big M, little m, because I get the M's confused. So you got to be really careful. You know, the hanging mass here, this guy is our big M, the bullet is little m. The initial velocity of the bullet is what? V. Then they tell us that the bullet passes through big M, through this pendulum bob, and then passes through, and then over here, the final velocity of the bullet after the collision is V over 2. Okay? Now, as a result of the collision, what happens to this big M here? So this guy is attached to a, where does it say right here? Stiff rod. Now, does it matter if the rod is stiff? It does, because look, if this were like a rope, what would happen as it started to go up? The rope would get what? Slack, right? So it's like it's attached like a stick. This rod here that connects to M is stiff. So as a result of the collision, big M goes up, 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 up. It's not going to fall because it's on a stiff rod. It goes up, 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 and it barely. So the problem tells us that the big M barely makes it through this swing. So what does the barely imply? The barely tells us that when big M is up here, what's its velocity? Basically it's 0. Or if you're like, well, Spaldo, it's making it through the swing. So okay. So you know, just make this 0.0000000000001. Okay. So it barely makes it, right? But for all practical purposes, what's the velocity up there? 0. It stops at the highest point, so velocity goes to 0. Now, the thing we're trying to find here is this: what is the initial velocity of the bullet before the collision in terms of the other variables, right? So look, we're going to be analyzing the collision. So what can we apply to the collision? So we're going to analyze the collision of the bullet and big M. What can we apply to the collision itself? Starts with a mo and ends with entum. Momentum. You can apply momentum to the collision. All right. So do these guys stick together or not stick together during the collision? They don't stick together. So you're going to go M1 V1 initial plus M2 V2 initial equals M1 V1 final plus M2 V2 final. So the bullet is going to be M1. The big M here is M2. So what starts out with no velocity? Before the collision, what has no velocity? M2. So this goes away. And okay, so now let's put it in terms of, we got to put it in terms of what they're doing. So what is M1? So I'm going to rewrite this equation, but now I'm going to do it big M, little m. So what is M1? Big M or little m? Little m. So it's going to look like this. Little m. Now what's V1 initial? V1 initial is just what? V. So we have MV equals, okay, so now we're over here. What's M1? Little m. Now what's the final velocity of the bullet after the collision? That's V over 2. Okay. What's M2? Big M. Now we have to figure out, the velocity of big M after the collision. Now how can we find out the velocity of big M after the collision? Well, look, after the collision, and actually, you know what, I should say immediately after. And by immediately, I mean like 0.01 seconds after the collision. Like the collision's done, and it's been done for like 1/10 of a second or 100th of a second. Immediately after the collision, what can we apply now? When the collision's done, can we use momentum? No, because you can only use momentum for the collision, right? So now we're looking at it after the collision. What could we apply? Conservation of Energy. What type of energy does this big M have right after the collision? Kinetic energy, right? Oh, and by the way, here's our 0 point. Our 0 point's down here. So what type of energy does big M gain? He goes up, 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 and he gains potential. Any kinetic up there? No, because he stops. So the kinetic that he has after the collision gets converted to potential of gravity. So this is going to be 1/2 big M V initial squared equals, so what's potential of gravity? mgh. Now hold on a second. What's that h going to be? 2L, right? Because it goes up not 1L, but 2L. So h is 2L. The m's cancel. So his velocity after the collision is going to be equal to, let's see. So we can't forget about that 1/2 right there. It's basically going to be 2 times 2 GL, like that, right? So this 2 is from the 1/2, and then that other one there. So now this is going to be, oh, and square rooted, sorry. We got to square root both sides. So take the square root. So this ends up being the square root of 4GL. So pull out the 4, 2 square root GL, right? So this is the velocity, that's the velocity of big M right after the collision. Does that make sense? So now we plug that in up here. So this is going to be 2 square root GL. All right, so now we got to do some algebra. So let's, I'm going to simplify this equation now. So this equation here simplifies to little m, let's see, little mv over 2 equal to 2 big M square root GL. Now look, some of you are like, where the heck did you get mv over 2? Well look, mv and then mv over 2, you got to bring this guy over, right? So we subtract him, right? What's mv minus mv over 2? mv over 2. mv minus mv over 2 is mv over 2. Okay, so now we simplify this and we're solving for v. So this is going to end up being 4m square root GL over little m. That's this velocity over here, right here. Does that make sense? Now look, final thing I want to say since we have a minute. When you're analyzing the collision, this is a common mistake that kids make. Can you apply conservation of energy to the collision? Can you say like, oh, so here's the collision, right? The bullet hits big M, right? Can you say, oh, the kinetic energy before the collision equals the kinetic energy after the collision? Only if they tell you what? That it's elastic. So you cannot do that. You cannot do that unless they say it's elastic. But what can you do? You can do momentum. Starts with mo, ends with entum. Momentum. You like this, don't you?